I'm Anil Kumar sharing with you a test paper on vectors and application. It's a very recent test paper, 2018. I would like you to copy these questions, try them out, and then look into my solutions. So on this page, we have 6 questions. You can copy them one by one. They are based on the applications of dot product and cross product. Here is page number 2 in right. So a few more questions, knowledge-based questions. Then we have question number 11 on page number 3. 2 more application questions. You need to find angle between the diagonals of a parallelogram, and you need to find whether the vectors are perpendicular or not. The last page, working with unit vectors, finding work done, and the value of k when area of parallelogram is given to us. Now we are going to take these questions one by one, solve them. I hope you already have a copy. So this is my copy of these questions, right? So we have 8 questions on this page. The next 8 are copied on the next page. So it's a lengthy paper. It might take about an hour to explain and provide their solutions, right? So feel free to watch this video in parts. Let's take them one by one, and I hope you do fairly well in your own test. The very first question here is, which of the following sets of forces acting on an object could not be in equilibrium, right? So the question here is, could not be in equilibrium. So the idea here is, whenever you do forces and they want to be in equilibrium, we are trying to make a triangle, right? An important property of triangle is that sum of 2 sides is always greater than or equal to third side. Correct? Now, what I mean by equal to? Well, if you see option B, which is 5, 10, 15, we could have forces like this, right? 5, 10, and 15. Do you see that? So they will become 0. So that is equilibrium. So you don't really get a triangle, but still you can understand the angle is 0, right? 4 plus 4 is 8, greater than 4. So that is okay. Not a problem. 6 plus 7 is 13, greater than 10, not a problem. However, 4 plus 5 is 9, right? And 9 is not greater than 10. So this will never make a triangle. So option D is your option. Correct? Question number 2. If dot product of 2 vectors is 0, then they are perpendicular. Is this statement true? So that's important to understand. So what we are saying here is that if A dot B is equal to 0, and you know what A dot B is, right? A dot B is magnitude of A times magnitude of B times cos of angle between them. That is 0. Now if that is 0, then this is possible if theta equals to 90 degrees, correct? So that means they are perpendicular. So it says if dot product of 2 vectors is 0, then they are perpendicular. Is this statement true? So I will say not always. Can you tell me why? Since even magnitude of A could be 0, magnitude of B could be 0. Do you see that? their magnitudes could be 0. Even then, you get them 0, right? So there is a condition which needs to be added, and that is for, let me write down here, for non-zero vectors. Now this condition is not mentioned here. Therefore, this statement is false. So I hope you get an idea, right? So it is not always true, but most of the time we ignore the fact that A or B or both could be 0, right? Question number 3 and 4. Find possible value of k for the vectors 13, 4, 2 and this to be perpendicular. So as we learned, their dot product should be 0, right? So let's find the dot product and equate it to 0. So that means 13k minus 5 times 4 is minus 20, minus 3 times 2 is minus 6 equals to 0. So that gives you 13k equals to 26, and that gives you k equals to 26 over 13, which is 2. So k equals to 2 is the solution. Perfect. Question number 4. What is the direction cosines of the vector 7, 4, minus 3 with positive z direction? Okay, so whenever you have to find the direction cosines, so that is the number which will give you the direction cosines. The key here is to find unit vector. Is it okay? Then you will get the direction cosine. Is it okay? So if this is the vector, let us say if the vector A is 7, 4, minus 3, correct? In that case, what is unit vector A? So I'll write unit vector like this. Will be vector 7, 4, minus 3 divided by magnitude of 7 square plus 4 square plus minus 3 square. Correct? So that gives me the unit vector A as, let me just add these up. So square root of, we have 7 square plus 4 square plus 3 square becomes positive, right, everything? Okay, so we get square root of 74. So we have 7 over square root of 74, 4 over square root of 74, and minus 3 over square root of 74. Correct? Now we need to find direction cosine. Is it okay? We need to find direction cosine. So that becomes the direction cosine. So we can write down our answer that the direction cosine is, so we can say cos of gamma with z-axis is minus 3 over square root of 74. Does it make sense to you? Right? So that is how we are going to answer this question. Question number 5. An airplane heading south has an airspeed of 600 kilometers per hour when it encounters a wind from the east at 150 kilometers per hour. How long does it take the airplane to travel 900 kilometers, right? So let's sketch the diagram. Since we are moving south, let us say this is airplane going south at 600 kilometers per hour. So we will call this as a velocity vector diagram. Correct? So this is 600. Okay, kilometers per hour. No need to write units. We can always include them later. When it encounters a wind from east, so this is north, this is east, right? So it encounters wind from east, so that becomes the wind from east, and this is 150. Okay, so definitely we get a resultant which is in this direction. Let's call this as velocity resultant R, right? Now you can always find the angle. Or we need to find time taken, and okay, so let's find the velocity first. Okay, let's find the velocity first. Now in this particular case, what we can do is, since this is a right angle, we can use Pythagorean theorem. So we say VR, this velocity magnitude, is square root of 600 square plus 150 square. Does make sense? So let's do it. So we have square root of 600 square plus 150 square, and that gives you 618,465.466, let us say. Okay, so that is velocity in kilometers per hour. Since we need to find time, we know distance is 900 kilometers. Time is distance over, so we are just working with magnitudes. Is it okay? So distance over this velocity magnitude. So in this case, it is 900 divided by 618.466 in hours, correct? So we already have this number here. So we'll just divide 900 by our answer, 1.455. So we get time as 1.455 hours. That's a good idea to write 0.455 in minutes, right? So we'll multiply this by 60 to get minutes as 27.3. So we could write this as 1 hour and 27 minutes. Correct? So that is how we can actually solve this particular question. Or you can say 1.5 hours. Okay. So now let's move on to question number 6. It says, for the vectors A, so all the vectors I have written in bold letters, 1, 0, minus 4, and B as 5, 2, 1. What is the scalar projection of B on A? So we want scalar projection of vector B on vector A, right? So this is first thing. And then we want vector projection of B on A. So we need two things. First, scalar projection, and then the vector projection. So let's understand the basic concept. So for simplicity, I'm just drawing vector A in this direction. And let's say vector B is something like this. Then the projection, which we're talking about, is the cos component. So this is the scalar projection. Is it okay? So let's say ON, right? So that is the projection of vector B on vector A. We are actually interested only in the unit vector A, not its magnitude. Correct? So what is the formula for scalar projection? Well, if I do the dot product of these two, so it is A dot B divided by the magnitude of A, divided by the magnitude of A. Basically, you can see if theta is the angle here, we are looking for B cos theta. Is it okay? The component of B along A, B cos theta. A dot B is magnitude of A times magnitude of B times cosine theta. Perfect. So that is what it is. So basically, just to recap on this, that is what scalar projection is, just the magnitude. Is it okay? So in our case, we have A as 1, 0, minus 4 dot 5, 2, 1, and magnitude of A will be 1 square, which is 1 plus 0 plus 16. Okay, so I just wrote the squares directly. So here we get 5 times 1 plus 0 plus minus 4, correct, divided by square root of 17. This is equal to 4 minus 5 minus 4, which is 1. So 1 over square root of 17, that becomes the scalar projection. So this is our answer of part A. Now to find the vector projection, we only need to add the direction to this, right? So now let's calculate the vector projection. That is of B on A, right? So the first one, just to make it double sure, we'll just say scalar projection, magnitude, right? Now the vector projection, what you can do is you can use a different formula also, which is A dot B divided by B dot B. That gives you the magnitude. So let me do that. So we have A dot B divided by B dot B, right? Times the vector B itself. So B dot B gives you the magnitude square, correct? Magnitude square. So you could do this and get your answer. That is one way, right? Or what you could do is, you already know this A dot B, 1 over square root 17, correct? I'm sorry, A is here, I'm so sorry. This is along B on A, I'm sorry. So it is A dot B over A dot A times the vector A, right? That gives you the formula directly. Or what you can do is that you can multiply this by unit vector along A, right? So that gives you one answer. Or what you do here is, as I'm saying, we know all this. We'll just multiply 1 over this by this, correct? So let me do this, okay. Or let me write down here. It is 1 over square root of 17 times the vector A, which is 1, 0, minus 4, over its magnitude 1 over 17. Do you see that? Because this is the magnitude of A, correct? So what you found here, this number, is the magnitude of A. Magnitude of A is 1 plus 0 plus 16, which is square root of 17. Do you see that? So that becomes the vector projection. So you could divide these by 17 to get your answer. So we get our answer as vector projection of B on A is equal to 1 over 17, 0 over 17, and minus 4 over 17. Is that correct? So that is how we could do once we have already calculated scalar projection. You don't have to do these dot products. That's what I'm trying to tell you, right? So you get the same answer. I hope the concept is absolutely clear, right? Question number 7. If ABC is a triangle with vertices A 0, 1, B 2, 0, and C 3, 3, then what is the vector projection of AB on AC? So we need to find vector projection of AB on AC. Now please do not sketch, right? That is not required. We have to save time whenever we can. So let's find AB. Okay, we want to calculate vector projection of AB on AC, correct? This time we are going to use the formula which involves dot products. AB dot AC over AC dot AC times, this is a scalar multiple, right? So don't get just ignore this. Let's write in brackets vector AC. So this is a scalar multiple. We need to find what AB and AC is. So let's calculate. AB is B minus A, right? So AB will be 2 minus 0, 0 minus 1, 0 minus 1, which is 2 minus 1, correct? AC, vector AC will be C minus A, which is 3 minus 0 and 3 minus 1, correct? So which is 3, 2. So now we can find the vector projection of AB on AC, which is dot product of these two, 2 minus 1 dot 3, 2, over the magnitude square, which is 3, 2 dot 3, 2, and in this direction of AC, which is 3, 2. Correct? So that is what it is. Let's calculate. 2 times 3 6 minus 2 in the numerator, 3 times 3 9 plus 4 in the denominator, 3 2, and that gives you, let me write down here, 4 over 9 plus 4 is 13, 3 2, or you could write this projection as, let's multiply, 3 times 4 is 12 over 13, right? And 4 times 2 is 8 over 13. So that becomes our solution. Is that clear? All right. So you can always go through these solutions, understand the concepts, and then move forward. Question number 8. A bolt is being tightened into a piece of wood. A 35 Newton force is being applied at the end of 30 centimeters. So this is 30 centimeter wrench. The force makes an angle of 70 degrees with the wrench. What is the magnitude of torque for this force about the end of the wrench, right? So we want to find the torque. Torque is cross product of the distance or displacement or radius times the force, correct? Now we are clearly given that the force makes an angle of 70 degrees with the wrench, right? So force makes an angle of 70 degrees and it is being applied 30 centimeters away. So that gives you the magnitude of distance times magnitude of the force times sine of the angle between them, sine theta. So in our case, distance is 30 centimeters. So we'll write this in meters since the force is given in newtons, right? So it is 0.30, right, divided by 100 times the force, which is 35 newtons, right, and sine of the angle, which is 70 degrees. So the units here are meters, this is newtons, and that is degrees, correct? So we can multiply and get our answer. So we have 0.3 times 35 times sine of 70 degrees, which gives us 9.866. Newton meters, right? So we can say torque Newton meters, we can say. So that is how we could actually solve this. Let's move on to question number 9. Question number 9. A wagon is pulled a distance of 180 meters. So we are given displacement of 180 meters. The amount of work done, we are given work done is 860 joules. And the magnitude of force is 16 newtons. At an angle of theta to the ground, what is theta? So we need to find the angle theta, correct? So what is given here is kind of like this. Let's say this is the wagon, right? Let's say this is the wagon, and the force is being applied at an angle, right? And what we are given here is a displacement and the work done. Both the things are given to us, right? Now, as you know, the work done is a dot product. So the angle, if it is angle is theta for us, then the work done will be the magnitude of force times the magnitude of displacement times cos of theta. Now here work done is 860. Force is 16 newtons, so write 16 here, right? And displacement is 180 meters cos of theta, right? So we can always rearrange and then say cos theta equals to 860 divided by 16 times 180, right? So let's do this and then we'll find theta. So we have 860 divided by 16 and then we'll divide this by 180. So in whatever we get 43 over 144. So now we can calculate what theta is. Theta is cos inverse of 43 over 144, correct? So we'll just to shift cos inverse of our answer, and that is equal to 72.6 degrees. Correct? So 72.6 degrees. If you want theta to the nearest degree, so we need to round to nearest degree. So we get the answer as 73 degrees. Is that correct? So that is how you're going to solve this question. So I hope it is absolutely clear, right? Question number 10. A plant with a mass of 10 kg is suspended from a ceiling by 2 lengths of rope that makes angle for 20 degrees and 50 degrees with the ceiling. So what we are given here is, let's say that is the ceiling, right? Now from this ceiling, there is a plant which is hanging with 2 ropes, kind of like this. Okay. Now these angles are formed as, let me write 50 here and 10 degrees there. Okay. And the mass of this plant is 10 kg. Now you have to convert this to force, and force will be 10 times 9.8. So that gives you 98 newtons, right? So that becomes the force now, with which it is acting downwards. We need to determine tension in each string. Let's say this is T1 and this is T2. So first step here is to draw the vector diagram, right? So first step is to draw a vector diagram. And then we'll find the tension. Now here is a very simple way of doing it. So what we do is we use this existing diagram. Now here we will do the resultant of this. So the resultant of this force can be placed here, right? So that becomes the resultant R, which is equals to the same as 98 newtons. Do you get the idea, right? One of the tensions is already taken care of. The other one, I will actually extend this here. Do you see that part? So when I do this, it is probably the simplest way of sketching the vector diagram. This becomes tension 1. Got it? Now we have to figure out the angles. Since that is 10, this is 90. I know this angle is 80 degrees. Now this is vertical. Okay, with the horizontal here 50 degrees, so this is 50, that is 10, so that becomes 10 and 50, correct? And this vertical is same as this one, which is 40, correct? So let us check if their sum is 180. So that is the check for us. So we'll do 80 plus 40 plus 50 plus 10 and see what we get 180. Perfect. So now you're sure all the calculations are correct. Do you see that part, right? So we have this particular triangle which we are going to work with. Now we know this resultant is 98 newtons. We know the angle opposite to this is 60 degrees, right? So combine these two angles. This is 60 degrees, correct? That should help you to find all the results. So easy it is. So T1 over, so we'll use sine law. Correct? So that's the triangle. So T1 over sine of 80, so see here, T1 over sine of 80 degrees should be equal to this resultant of 98 over the angle opposite 60 degrees, sine of 60 degrees. And that is a constant, and this constant is also equal to T2 over sine of 40 degrees. Does it make sense? Correct? So easily you could always write T1 as 98 times sine of 80 degrees over sine of 60 degrees, and T2 as 98 times sine of 40 degrees over sine of 60 degrees, and calculate your answers. So we'll do 98 times sine of 80 divided by sine of 60, right? And what do we get? 111.4. 111.44. For the other one, we have 98 times sine of 40 divided by sine of 60. I actually avoid making brackets. I just keep on calculating as we move. 72.74, right? Now let's see what accuracy is required. It says determine the tension in each length of the rope. Nothing about the units. So we'll use one decimal place. Okay, so we'll round this to one decimal place, 11.4 newtons, and the other one as 72.7 newtons. Do you see that? So those are our answers. So T1 is 111.4 newtons. T2 is 72.7 newtons. Great. I hope the steps are absolutely clear, and that is the best way of solving such questions which involves chords and tension in the chords. Correct? Question number 11. An airplane is traveling south 70 degrees west with a resultant ground speed of 414 kilometers per hour. We normally read this as 70 degrees west from south. The nose of the plane is pointing west with an airspeed of 425 kilometers per hour. Determine the speed and direction of wind. Let's try to make a diagram. So let's say that is our coordinate plane where this is north for us. Right? It says an airplane is traveling 70 degrees west from south. So this is south for you. So it is going in this direction kind of. So this is the direction of the plane. The airplane is traveling 70 degrees. So from here, this angle is 70 degrees. West from south. With a resultant ground speed of 414. So this is the resultant speed and this is 414. So we'll say VR equals to 414, correct? Kilometers per hour. The nose of the plane is pointing west with an airspeed of 425 kilometers per hour. Determine the speed and direction of wind. Now in this case, it is saying that the nose is pointing west. That means the plane actually points like this, but it is moving in this direction. Do you understand? It is pointing here, but moving along this line. So look here. It is pointing, but moving along this line. The reason is that the wind is pushing it down. And we need to find this velocity of wind. We need to find this velocity of wind. That is the question for us. What is this velocity of wind? So the nose of the plane is pointing west with an airspeed, actually airplane speed, here it should be, of 425. So this speed is 425 kilometers per hour. Now, but it is going at a resultant speed of 414 in this particular direction. So you have to find V velocity. Now from this given situation, we know two angles, right? So we know this angle as 30 degrees since it is pointing west. And we know two sides. So side angle is given to us. We can apply the cosine law. So if you apply the cosine law, you can find the velocity VW, which is equal to, let's write square first and then we'll square root it. Square of 425 plus square of 414 minus 2 times 425 times 414 times cos of the angle between them, which is 30 degrees. I'm sorry, 20 degrees. Sorry. 90 minus 70 is 20 degrees, correct? So that is what it is. And that will be square root of all this. So let's calculate this value first, which is 425 square plus 414 square minus 2 times 425 times 414 times cos of 30 degrees equals to. So we have a number which is 47266.6. Well, square root to find velocity. So square root answer equals to 217.40. So that becomes the wind velocity in this particular direction. Is that clear? Now we need to determine direction of the wind also, right? So direction of the wind, let's find this angle. Let's say this angle theta. We can use sine law now to find the angle. So we know wind velocity and angle 20. We know the side opposite is 414. So to find this angle, let's say, let me write this as ABC, let us say, okay. So the angle at A, which is called as sine of A, over side opposite is 414, equals to sine of 20 degrees over what we calculated, 217.40. So sine A is equals to 414 times sine of 20 degrees divided by 217.40. So we have 414 times sine of 20 degrees divided by 217.4. That gives you 0.6513. So angle A equals to sine inverse of 0.6513, which is shift sine inverse of our answer equals to 40.64. 40.64. So this angle is actually 40.64, right? So we could round this to determine the speed and direction. So they have not mentioned. We'll just round it to a whole number, right? So we'll say 41 degrees from this direction. Now, it is always a good idea to write these numbers or the angles as a bearing angle, correct? So basically it is 40 is less than 90 degrees. So diagram, it should have been like this kind of. Is it okay? So what we get here is we can say bearing angle. That means from north, it is 90, is like 90 plus 40, correct? 90 plus 40.6, that gives us 130.6 degrees bearing of this. So let me write down the answer. Answer is that the wind velocity is 217.4 kilometers per hour from bearing angle, bearing of 130.6 degrees, correct? So that is how you can actually solve this particular question. So I hope that is absolutely clear. Question number 12. The vectors A and B have length 2 and 1 respectively. The vectors A plus 5b and 2a minus 3b are perpendicular. Determine the angle between A and B. So we are given the magnitude of vector A as equal to 2, magnitude of vector B as equal to 1. And when we say that these two vectors are perpendicular, that means dot product A plus 5b and 2a minus 3b is equal to 0, right? That's what it means. We need to find the angle between A and B. To find angle between A and B, what we can do is we can find dot product of A and B, which is magnitude of A times magnitude of B cos theta. And from here we can find cos theta as dot product divided by the magnitudes of A and B. So let's first find A dot B from this particular expression, right? So A times dot product 2A gives you 2 magnitude of A square minus 3 A dot B plus 10. We can write A dot B or B dot A, one and the same thing, commutative property, minus 15 magnitude of B square, right? Since magnitude of A is 2, we can write this as 2 square. Combine these two, 10 minus 3 is 7, 7 A dot B. 15 times 1, so we get minus 15, right? Let's say 1. All this is equal to 0, right? So we can write this all equal to 0. So from here, we can take 7 A dot B on the other side. So we get 7 A dot B is equal to 2 times 4 minus 15, which is 8 minus 15, which is minus 7. So A dot B is minus 7 divided by 7, which is minus 1. Right? Now, when you get A dot B as minus 1, we can always write this here, A dot B as minus 1, and we can find what cos theta is. So cos theta is equal to A dot B, we calculated as minus 1. So we'll write minus 1 here. Magnitude of A is given to us as 2. Magnitude of B is given to us as 1. So we get A cos theta as minus half. So we need to find angle between A and B is negative half. Now that really means that we are looking for a solution in quadrant 2, right? So as you know, cos is negative in quadrant 2. So that is the angle which we are looking for. Right? So we can always do cos inverse. Shift cos inverse negative 0.5 is equal to 120 degrees. So theta is equals to cos inverse of negative half, which is 120 degrees. You could actually also find the acute angle and then 180 minus the acute angle, or you could also use the special triangle, right? So we could always use this special triangle for half, which is 1 to square root 3, where this angle is 60 degrees, correct? So from here you get acute angle of 60 degrees and theta will be 120 degrees. Do you see that? But you could calculate directly also. So I hope that is absolutely clear. So let's move on and do question number 13. Question number 13. A parallelogram is determined by the vectors A minus 2, 5, B is 3, 2. Determine the angle between the diagonals of the parallelogram. So we'll just sketch a parallelogram. It says these are the two vectors. So, okay, let's kind of sketch this. One vector is minus 2, 5. So that means minus 2 and 5 somewhere here. So we'll just say this is one vector. The other vector is 3, 2. So 3 and 2. So somewhere there, right? So let's say this is the other vector. Okay. The diagram is not to the scale, right? But we're just sketching it. It's not required to be sketched also. But okay, it gives you some sense. Anyway, let's complete this parallelogram. Okay. And what we need to find is angle between the diagonals. That is, we need to join these and this, and we need to find that angle, correct? So let me label this. So you say OA and B, where this is the vector A, that is the vector B, and this is the angle theta we are interested in finding. Correct? Let's find the point C first, so that we can get the diagonal. How do we get C? C is B plus A, right? So we can get OC as equal to vector B plus vector A. So in our case, it is 3, 2 plus minus 2, 5. And that gives you, when you add this up, 1, and 2 plus 5 is 7. So that is the position vector OC, 1, 7. Correct? Now, one of the diagonals is OC. This is one of the diagonals. Now let's also find the diagonal AB. Let's find the diagonal AB now. The other diagonal. So diagonal A to B will be B minus A, will be vector B minus vector A, which is 3, 2 minus 2, 5. So 3 minus 2 becomes 5. 2 minus 5 becomes minus 3, right? So that becomes AB. Now to find the angle, we have OC dot AB divided by the magnitude of OC times magnitude of AB. So that is the cos theta. Is that okay? That is what the angle is. Now, OC dot, these are your vectors. So we can find this as 1, 7 dot 5 minus 3 divided by magnitude 1 plus 7 square times 5 square plus minus 3 square, correct? So we can say cos theta is equal to 1 times 5 is 5 plus minus 21 over 7 square plus 1, 50, right? Square root times, here we get 25 plus 9, 34, right? 25 plus 9, 34. So that's what you get. We can now use the calculator to find the answer. So we have negative here on the top. 21 minus 5 is equal to 16 over square root of 50 times 34, which is 10 square root 17, right? So that is what it is. So we get theta equals to cos inverse of this angle minus 16 over 10 square root 17. So we have negative 16 divided by, within brackets, 10 square root 17 equals to, and we'll do shift cos inverse of our answer, and that is equal to 112.8. So 112.8 is one of the angles between these two diagonals, correct? So that becomes an obtuse angle. So we can say the angles are 112.8 degrees. So accuracy, okay, let's go with this. Or it could be an acute angle, so we do that minus 180. So either one of them. So 67.2 degrees. Is it okay? So that is how you can find angle between the diagonals. So it's kind of important to find the diagonals and then the angle. You should not find angle between the vectors. So that's a caution. So I hope that helps. Question number 14. Determine the unit vector that is perpendicular to A and B. So unit vector perpendicular means we could find cross product. So whenever you do cross product, you get perpendicular vectors, correct? So we'll do A cross B to find the vector. So the method which I use normally is we can do ijk. These are the unit vectors, and A is 3, minus 2, 7. B is 2, minus 1, 2. And then we'll solve this. So minus 2 times 2 is minus 4. Minus this gives me plus 7. Minus j. 3 times 2, 6. Take away 14. Plus k. 3 times minus 1. Minus 3. Take away, that becomes positive 4. So we'll write this as, so that gives you 3i. Minus, let's use calculator, right? So we have 6 minus 14, which is minus 8, but makes it positive 8j. And here we have plus k. So that becomes the vector. To find the unit vector, so let's say C is the vector. So the unit vector will be the vector C divided by the magnitude of vector C. So we get 3i plus 8j plus k divided by square root of 3 square plus 8 square plus 1. You may write 1 square, right? So what we get here is 3i plus 8j plus k divided by square root of, let's calculate this. So it's 9 plus 64 plus 1, right? So 74. So the unit vector, so unit vector perpendicular to A and B is equal to, so we can write 3 over square root 74 I plus 8 over square root 74 j plus k over square root 74. So that is how you could do it. So I hope the steps are absolutely clear. Let's move on. We're almost at the end. Second last question, question 15. A block slides 42 meters down a ramp that makes an angle of 60 degrees with the ground. So we have a ramp here that makes an angle of 60 degrees with the ground. And a block slides 42 meters, let's say from here to here, for example, right? That makes an angle of 60 degrees with the ground. Determine the mass of the block if 10,400 joules of work is done. Okay. Now in this particular case, we need to find the mass. We are given work done. So work done is basically dot product of displacement with force, correct? That is what it is, which is magnitude of displacement times magnitude of force times cos of angle between them. Now in this particular case, you have to be very cautious that normally, this is the normal, right? The weight actually acts downwards. So that is the direction in which the weight acts, the force acts. Now this force will make the body move. Now in this particular triangle, the angle is 90 degrees here. So this angle is 30 degrees. So basically the angle is 30, not 60, between the force, which is due to weight, which is mass into gravity. Do you see that? That is the force which is acting because the gravity acting downwards, right? So then work done is given to us as 10,400. Let's substitute the values. Displacement is in meters, 42 meters, and we have an angle which is 30 degrees, not 60, right? Force is mass into gravity. So we don't know what mass is. We'll write force at present, right? So we'll say magnitude of force and cos of angle 30 degrees. Now this is a common mistake, avoid it. Angle is between the two forces and the displacement. Is it okay? Now from here we can find what force is. So the force in the magnitude is 10,400 divided by 42 times cos of 30 degrees, right, in newtons, since all these units are in meters, MKS units. So we have 10,400 divided by 42, and we'll divide this by cos of 30 degrees, which gives us a force of 285.9258. Let me write like this. How does it matter? Now force is mass into gravity, right? So this is mg. So this force is equals to m into g, mass into gravity. And we know gravity g is 9.8, right, kg per meter square, all right, MKS unit. So from here we can write mass is equals to 285.9258 divided by 9.8. So we're going to divide this number by 9.8 to get the mass, which is 29.17, right? So since they are all whole numbers, we'll round it to whole number. So we'll say it is 29 kg. So our answer is 29 kg. Okay. Let's move on to the last question, which is question number 16. Determine the values of k such that the area of the parallelogram formed by these vectors, vector A is k plus 1, 1 minus 2, vector B is k 30, is 41 square root. So area of parallelogram is what? Is the cross product, right? It's the magnitude of A cross B, right? So that is what area is, right? So we are given the area is square root of 41, and we can find the cross product between these two. So that means k plus 1, 1 minus 2 cross k3, 0. Do you see that? So that gives you the answer, correct? So from here we can always find the value of k. So let's find the cross product. So I'll use the matrix method here again, and then we'll solve it. So what we have here is, let me write I, j, and k, the unit vectors, k plus 1, 1 minus 2, and here we have k, 3, and 0, right? So that is the A cross B, correct, equals 2. So let's calculate it here. So we get I, 0 minus becomes plus 6, minus j. So for j that is 0, and this one is 2k plus k, which is 3 times 3k plus 3, let me write, right? So for k, 3k plus 3 minus k. So that becomes 6i, and here we get minus 2jk, and here we have vector k times, okay, so I, j, k are the unit vectors, okay, so unit vector k, and the constant is 2k plus 3. Is it okay? Constant is 2k plus 3. So that is the vector. The magnitude of this vector is how much? So let's find out the magnitude of A cross B, which is square root of 6 square plus minus 2k square plus 2k plus 3 whole square, right? That becomes the magnitude. So this is equal to square root of 36 plus 4k square plus, when you do this, you get 4k square 2 times AB, 4 times 3 is 12k plus 9, right? So that gives you, this is all square root. So that gives you 4 plus 4, 8k square plus 12k plus 9 plus 36 is 45 square root. So we can, since we calculated all this here, we can substitute and find k. So what we get here is that square root of 41, so I could write 41 is equal to 8k square plus 12k plus 45. Is it okay? So taking this to the right side, I get 0 equals to 8k square plus 12k plus 45 minus 41. So that gives you 8k square plus 12k plus 4. I could divide all by 4, so I get 0 equals to, if I divide all by 4, I get 2k square plus 3k plus 1, right? So we are looking for product of 3, sum of 3. So we need to actually work out on quadratic formula to calculate this value, equals to 0. Is that okay? So we can find here that k is equal to minus b, which is minus 3, plus minus b square, which is 9, minus 4ac, 4 times 2, 8, okay, over 2a, which is 4. So that gives you minus 3 plus minus 1 over 4. And this gives you two solutions, which is negative 4 over 4, which is negative 4 over 4, which is 1. Or if I add, we get negative 2 over 4, which is negative half. So the value of k for us is, so we get k, answer, k equals to, let me push this page a bit, okay. So k is either equal to 1, negative 1, I'm sorry, negative 1, or it could be negative half. So these two will give us the answer for the given question, right? So I hope you find my solutions interesting and useful. At least you understand the methods correctly. I might have done few calculation mistakes. That's okay. So do your calculations yourself and then see what you get. Correct my answers if they're wrong. Okay. Thanks a lot for watching. I hope you enjoyed this journey of learning. Feel free to write your comments and share your views. And if you like and subscribe my videos, that'll be great. Thank you and all the best.